Hello, everyone. My name is Tyler Jubal. I'm the engineering manager of the platform team here at People Data Labs, and I'm here today to talk to you about infrastructure as code and Monorepos. So before we get into that, though, I want to give you some context about us and our company. So at People Data Labs, our mission is to serve fresh and accurate data sets to customers at scale. And we deliver this through APIs and data licenses as products. These data sets are built with thousands of sources, and we have a very strong focus on security and compliance throughout. And for example, too, I've included the record of what People Data Labs as the product thinks about People Data Labs, the company. If you're interested in more, please do check out our website. And within our engineering organization, as a visual diagram here, I've included all of the teams that we have internally. So on the right side, you'll see all of the product focus teams that each build products that individually do something for the business, right? So we have our web stacks, we have our APIs, our internal applications used for operation purposes, and as well as a lot of custom stuff building and delivering the data that our customers use. All of these teams are first-class citizens of the platform, which is the part that my team maintains, which includes the software development lifecycle, as well as the end environment, the live environment where the networks and accounts and so on, where the services get deployed to. We also collaborate very closely with the security team, whose job is making sure that as we go through this process, we maintain a very strong security and compliance posture throughout. And a lot of the baseline changes that come in through that process flow in through the engineering teams by the platform. And so with working on this, our challenges is one, like everybody else, right? We want to be able to iterate. We want to be able to iterate very rapidly. And in doing so, we need to be maintaining a large a quality data set at scale, which is a pretty specialized problem in its own, and it's something that we've been used to doing for a very long time. And it's also part of our core value proposition. And while doing so, we of course need our systems to be performant and reliable, especially when it comes to customer-facing APIs, right? If a customer submits a query, using our data set to our APIs, they want that answer reliably, they want it very fast. So to support real-time use cases, we have to maintain very strong security and performance availability needs. And in doing all of this, again, we need to be continuously improving that security and compliance posture that we have. It's something that, due to the nature of our business, and also it's this very rapidly evolving thing, and it's very important that we need to be ahead of the game here and be leaders in that space. And within all of this, we want to do it with a self-service modeled infrastructure. And by that, I mean, rather than being an infrastructure team whose job is to do a lot of operations on behalf of everyone else, we'd rather provide people the tools to do things effectively, do things safely on their own. So that way we're not as much of an operations gatekeeper, and people can be empowered rather than have to go through red tape to get access to resources. And moving on a bit more into the development lifecycle. So before we get into the Monorepos stuff, I want to give a quick, simple model of what a modern software development lifecycle looks like. So starting from left to right, you have the code for your service to start with. This includes the business logic as well as the infrastructure definitions through something like Pulumi or Terraform. All that code goes into a repository, which allows version control. You have a deployment pipeline their job is to take the code, right, and bring it to the live environment. And throughout that process, you'll usually have an infrastructure as code stack, which just maintains the state of what's been deployed already, what you want to be deployed, and then it takes the difference of them and proposes and executes change sets around that. Eventually, it should go to your live environment of choice, something like AWS. None of this is particularly new, right? This is very standard stuff. But then the question is how do you scale this out into multiple services that are maintained across your engineering organization? So the very well understood way of doing this is by just scaling out the same pattern up to the live environment. So if I'm deploying 4 services, and I might have 4 repositories, each with their own sets of code, each with their own pipelines for deploying it, and so on. This is a very straightforward thing to understand, and it scales quite cleanly as long as you're going from left to right. And there are also a lot of tools built around this pattern that like to assume that a repository is its own individually deployable thing. You can make a lot of stuff simpler if you can assume that. And so a lot of tools do. There are some challenges that can arise, though, when sharing code across the repository boundaries, because in order to do so, right, that repository needs to be publishing its code as package somewhere, usually with versioning, and now there's a release cycle, and then the other repositories needs to pull. So there's a layer of indirection that adds quite a bit of friction. into reusing that code, which can sometimes not be desired. So if you want to do that very regularly, right, then that's something you have to work through. And then there's also on the subject of raising the baseline. Like if we say that we want all of our code to pass this like static, analysis check for security reasons, right? Or we want all our repositories to be configured a certain way, or we want all of our deployment pipelines to roll in this update to have this new behavior. That can be very difficult to do when you're talking about dozens to hundreds of repositories that each have to have this code, stuff applied. And both of these challenges were recurring like pain points for us. So a couple of years ago, we made a switch to something like this, where rather than having one repository for each individual thing, we just decided to fold it all into one customized repository with one customized deployment pipeline that's still able to deploy those same number of services at parallel. So comparing the both side by side, it's relatively self-evident in that most stuff doesn't actually change. Like the code still mostly stayed the same, right? The number of services stayed the same and actually increased because it became easier to add more. We found once that didn't involve setting up more repositories and deployment pipelines in addition to that. So by consolidating that and putting everything on the same lifecycle, a lot of interesting things tend to happen. So one of them being like, without these repository boundaries, where you can actually do just about any sweeping changes with one or two commits. And I say two normally because once you reach a certain scope, it becomes pretty much always a practical choice to do it in at least two. So that way you can have a window, right, where both the old and the new way are available before you remove the ability to do the old one. Otherwise, you end up doing a lot of very plan-heavy and risky kind of motions, and if something doesn't go well, it's really not good. So it's usually the practical choice to just de-risk that and do these things in stages. There's also a lot to be said about standardization there too, because when you have your code base kind of broken out into different independent repositories, right, and you want them to all be on the same page about some things, that generally tends to require like a bit of conscious effort to acquire and to maintain when you want it. Versus when you're all working within the same pipeline, the same life cycle throughout, you get a lot of that just as kind of a way of life. You don't really have to think about it. You sort of take some of that stuff for granted, especially if you have some attractive traits like I have the ability to pull in whatever library that I want, and just knowing that it'll all work. There can be a lot of benefits there. And then there's also a lot of problems that that could normally be like something that you only find out once you roll up new changes that you can resolve up front. Like for example, if we can run all of our unit tests in one go throughout the entire code base, then if there was a repository boundary and there was a change. So if I am working on a service, right, and then there's a library that I like to depend on, and I have unit tests within my service that assume that the behavior of this library is going to be this certain way, then that would mean that if a breaking change came to that behavior that was caught in my test suite, but not that one, then that would effectively have the same effect, and you would realize that as soon as that change is being proposed, instead of after going through that life cycle, those like separate decoupled life cycles, right? And so there's a lot of potential here to figure out problems before you actually try to deploy and integrate new updates to things, which can save you a lot of time in the long run. There's no silver bullets to this though, and there are some risks to keep in mind and to know what you're signing up for, before you make consider this change. The big one being that by having one repository and one deployment pipeline that has to do a lot at once, you introduce a new layer of bottlenecks to come in for performance. And usually ends up being a continuous point of maintenance that you have to keep providing, right? In the journey from going from 10 services, let's say, to 100, you're probably going to find many ways throughout that need to be adjusted in order to maintain like a strong level of performance. So that way you're not having a poor like experience as you're like sitting and waiting for things to deploy or for tests to run or so on. And so it's very important to be on top of that. There's also, just due to this large degree of customization necessary, a lot of off-the-shelf tooling that is less accessible to you than you would have if you had that simpler model of just having every repository being an independently deployable thing. You end up having to take a bit more time to integrate the tools that you want into your stack that make it available for everyone. And then also, again, going back to resolving problems up front, sometimes it's not desirable, and sometimes you actually do want to defer changes, especially if you're doing like a very POC heavy thing, like rolling out a transformer model into an API or something like that. Not that long ago, we had a pain point come along, right, where someone wanted to add TensorFlow, so that way they could test like an experimental thing, but then couldn't actually get that through the door until they had figured out how to make all of the dependencies of TensorFlow work amongst like our primary set of requirements. And sometimes that can add friction into like experimental stuff where you may not want to otherwise. But there are also some other like really interesting things that happen in this. So if I have our application behavior, as code has always been, right? But then we also turn our infrastructure into code with Pulumi or Terraform or CloudFormation or whatever. And then you have the policies for what you can do with both of those things also included in code, all of that in the same repository. Then that leads to some pretty interesting outcomes. One of them being that if at any given point in time, right, there's a commit hash that describes the goal state for just about the entire organization, and that in order to change these, the root of the change control for all of this comes in through the pull request to submit changes from where we are now to where we want to go, and this can be used to basically fold in just about anything that you could think of, from like network configuration changes to schema evolution to standard like application code changes to adding new services and so on. These things that could require a lot more process to do normally, right, could just be done by submitting a pull request that edits some config file or something like that, which has some attractive properties in that anybody can understand how and propose like a change in the clearest possible terms. And then you get to decide what's needed to approve that change, right? And then your pipeline can automatically deploy the change with basically any scope that you can think of. That can lead to some very powerful, interesting like ways to work where you don't have to deal with as much as red tape. It's all very technical and it's all very driven by the deployment pipeline that engineers have access to. But however, like that comes with a lot of that requires a bit of control to do safely. So let's talk about how we can model and work with that control. So one way that we like to view this internally within our company, within our team, is that we imagine that all of the resources and like options available to you, through your Pulumi providers, kind of fit into one of these four bubbles. And these are all subsets of each other. So what I mean is that each one of things fits into one of these, being like that it's possible, like I could do this, versus I actually can do this, versus something that I should do, versus something that this is something I normally do, this is something that I do by default. And generally speaking, like every setting, every resource is going to be somewhere here, whether or not like you explicitly put it there. So we're going to go through these one by one and show you a bit more about what I mean. So starting with the things that are possible. So really what I mean by this is this includes all of the resources and all the settings from all of the providers that you connect into it. And the way that you manage this is simple, right? By adding and removing providers that continuous delivery has access to when it does its deployment process. So if I, as an engineer, right, I have access to the Pulumi AWS provider, I might be able to spin up EC2 instances, sure, that's possible, but it might also be possible to submit valid code that adds another account. Maybe that doesn't mean that I should be able to do that, right? But that's something that's technically possible to do, to submit valid code to do that. So the next level of control from there is what you actually change within the access policies of your deployment process to make it like truly be available for use during deployments. And so this is like a hard access policy boundary, essentially. And normally this can be broad in scope, right? But really what this sort of represents is the pool of like services and tools available for engineering teams to like search for and like look in and, and grab from and try to use. Sometimes not all of this stuff is evaluated. So depending on what you need for security policies, it may be necessary to have a review of something before you actually roll it out into like a production environment, right? But having all of that being available frees engineers up to a pretty large degree to be able to look elsewhere when the established solutions that they have are not meeting their needs. But when you do have things that can meet their needs, it can really be helpful to have another level of things that are available, right, that you've actually evaluated, that you preferred, that you've set practices, documentations around. These are your golden paths. So these are areas where like where like for like a specific like use case, right? You've looked at alternatives. You've figured out one thing that works, and then you've decided that that's what should be like the way that we do things. And during that conversation, that might have involved, many engineering teams, security, like whatever you needed to be involved to establish that. It's very helpful to have a lot of that laid out up front. So that way you could, people can, one, save the time from having to dig every time they build something new, but also to have like a stronger degree of standardization. So that way people can generally go across and understand what's happening around them, even if it's not something that they actively work on and maintain. So having another like layer in there for things that you prefer people to use can be very useful, even if they're not required to always use it. And then there's the last bubble, which is different from the preferred in that like this is what people might be doing without realizing that they're doing, like by default through the tooling. And the way that you manage this is through custom libraries and abstractions, like component resources and Pulumi are a pretty solid way of doing this. This is where you get a lot of power from, because things that you can make by default, right, are if I can make a if I can make a problem something that is solved by default for me, then that frees me up to from ever having to think about that, and then instead I get to spend my time working on like the problem that my business actually has. So this is where you get a lot of the power from platform work, but it can also be very risky, because in order to change defaults to make something that was default behavior not, or the other way around, usually involves a breaking change if that's something that's been used already. And so because of this, you really don't want to be fast and loose, whereas you can be a lot more flexible with what you consider preferred versus, oh, that's just available. Here you want to be very, very careful and very thoughtful from it, from what you do there. But when it comes to maintaining like the security baseline requirements, having it being done by default is by far the best and most effective way to do that. Because again, you're freeing engineers to focus more so on the specific problem that they have that's actually going to help advance your business and get you to where you need to go. So with that, before we wrap up, I want to make one other point here, in that a lot of the ideas that I talked about here, or out of all of them, very little actually truly requires working in a monorepo. I do think that the ideas can have a lot of synergy with each other, and I think that the monorepo has led to a lot of success in our infrastructure engineering strategy. But your mileage may vary. Every organization is different. But with all that said, I hope that the ideas and models that are discussed here can help you see the infrastructure, like development infrastructure as a topic, in new and exciting ways. So with that, thank you for your time. I hope that you enjoyed this. And if you have any questions or just want to chat, feel free to shoot me an email or reach out to me on LinkedIn. Thank you, everyone.